Hi everyone, in this video we're going to have a look at some applications using our trig functions. To start off with, we've got our temperature, T degrees, during April, uh, given by T equals 17 take 4 sine pi on 12 T. And we've got time little t in hours after midnight. And the first part of the question asks to find the temperature at midnight. So at midnight, that's going to be our initial position, initial time, um, which is going to be when t is equal to 0 because we're at midnight. So we just need to find out what our temperature is at midnight. 17 take 4 sine of pi on 12 times 0. So if we work that out, we get 17 take 4 sine of 0. Sine of 0 is 0, 4 times 0 is 0, so we get our temperature is 17 degrees Celsius. So that's our part A. Part B is to find the minimum temperature during the day and what time it occurs. So, given our function, the minimum value is going to occur when sine of pi on 12t is equal to 1 because sine oscillates between 1 and 0. We've got an amplitude of 4. So if you're thinking about it graphically, usually sine oscillates between 1 and -1, except now it's going to oscillate between -4 and +4. We've got a phase shift of 17, which means it pushes our equilibrium point up 17 units. So our minimum temperature is going to occur when we have our equilibrium point below using our trig function. So when is this the minimum spot? So it occurs when it equals 1, and we can find that when our temperature is equal to 17 take 4 times that 1. So it's essentially just 13 degrees. So that's going to be our minimum temperature. Working out when that occurs. So we don't know when it occurs at this stage. We just know that this function here is going to be our minimum point. We can solve for when sine of pi on 12t is equal to 1. So we're going to solve this. So solving this equation, we find that pi on 12t has to equal pi on 2 from our unit circle. Sine, when sine is 1, that occurs at pi on 2. And then solving for t, times by 12 divided by pi, we get t is equal to 6. So the minimum temperature occurred at 6 a.m. Part C is looking at the interval in which the temperature, or over what interval did the temperature vary. So in other words, we're really looking for our amplitude. So our amplitude, and looking at the range based on our amplitude. So our amplitude in this case is our 4. We've got an equilibrium spot at 17. So 17 plus 4, 17, take 4. So we get 21 and 13. So it varies between 13 degrees and 21 degrees. We're looking at the period and sketching the graph for now. So looking for the period, 2 pi on n. We'll have 2 pi divide n, which is pi on 12. Two pi times 12 on pi. So flip and multiply. So 2's cancel, we get 24, which makes sense because we've got 24 hours in a day. So that's quite handy. So we're going to have one full oscillation during the 24-hour period. Dividing 24 into 4 equal parts. So every 6 hours we're going to oscillate. So just as a quick little sketch, we've got 0 to 24 and every 6. Okay, and we start at 17, we go down to 13, up to 21. And we've got the sine graph. We've got a minus signed graph. Usually it looks like this, but being a negative sine graph, we're going to be like that. So it's just a matter of connecting the dots where appropriate. I'm just going to pause the video here and make a new page for our last bit. Okay, so for the last section, we're looking at if the temperature was below K degrees for 2.4 hours, we need to work out what that value of K is. So if the temperature was K below K degrees, we'll call this K. Alright, so it's below this degree. We don't know how much it is. It might be up there, but we're not quite sure. So if we cut the graph at that position, okay, it means that this distance in here is 2.4. So if we work out what that is, using this information, we'll be able to work out what K is, which means that the distance between 6 and the end point there and 6 and the minimum point there has to be half of this. So it's half and half gives us 2.4. So this should be 1.2 and 1.2. So it's between 6 plus 1.2, so 7.2, 6 below, so 5.8. So it's between times 5.8 and time 7.2. So already we've got some information we can use now. Sorry, 4.8. It should be. It should be a 4. So 4.8. So there are our endpoints. So if we substitute each of those endpoints, we'll be able to find what our temperature is. So we can use either one. Let's use 4.8. So our temperature formula was 17 take 4 sine pi on 12 times T, which is now going to be 4.8. And if we work that out, we find that it's about 13.2. So therefore, we can say 13.2, and the temperature is below 13.2 degrees. Sorry, Our K is 13.2, so our temperature is below 13.2 degrees for 2.4 hours. So that's all for chapter 10.4. Thanks for watching. Have a go at the questions.